In this video we're going to look at an option on the Sims toolbar, and the Sims toolbar is available under the View menu, and when enabled this third toolbar is displayed, and the toolbar button is labelled split into multiple tiles. And the idea is to make use of the page tile format display to organise a display that helps to look at features within a survey spectrum. So we'll go for 9 tiles, and this has a default of 3 rows / columns, and these rows / columns are divided into 3, 3 and 3. So if I say OK to this, the display will currently look in this form, and the selected VAMAS blocks were displayed in the scroll list. So we now have 9 tiles, of which there are 8 that are displaying data. This one's empty. So let us just rearrange this. Rather than using 3, 3 and 3, what we'll use is 1, 4 and 4. So now, rather than having a regular array, the top one represents the survey spectrum, and then there are a set of tiles that are displaying narrow scan spectra. Now in this particular case what we're going to do is concentrate on the survey spectrum. So let's first move the display in a direction that is more conducive to the survey data, and we'll go for a different display on the y-axis, and we can turn off the residual because we're looking at survey data rather than fitted data, so no residual is required. And currently the display is showing 9 display tiles, they're just 8 of them are empty. So what I'm going to do is split the survey data. The number of new tiles is 8, so when I say OK, the spectrum that was selected is the basis for the data that are displayed in these 8 tiles, and they all represent intervals that have been pulled out over this range of energies that you see in the survey spectrum. So we can see, for example, here we've got mostly background and a small peak that would be difficult to see if we were just looking at the survey spectrum. So these display tiles are simply showing you different intervals from the same VAMAS block, and it's this one that's highlighted here with the red box around it. So if I bring up the element library and then select, say, the oxygen, we can look for oxygen peaks. So there's a feature here that could be the oxygen peak, but because we can also see that the background signal here where there should be an auger is displayed here in this display tile, you can see there's actually quite a small oxygen auger peak. So if this were an oxygen peak, then we would expect to see a significant auger peak to match this, because this is the oxygen 1s, and the oxygen KLL must appear in proportion for a given X-ray source to the oxygen 1s signal.